Okay, so the last passage at week 5 starts on page 412, and it starts with question 9. And this is your fighting scientist passage, so all of these are going to be EMI standards. The first one, which of the following assumptions was made by Lavoisier? So if we go back into the passage, it tells you that you're going to have to read the Lavoisier definition. So, he believed that all acids showed the same observable properties because they contained one common substance. Because he primarily knew of strong acids, he believed the common substance was oxygen. He believed that a metal reacting with an acid would combine with oxygen to produce a calx. The calx would then further react to the acid to form the salt. Hydrogen, the other component of water, was released as a gas. The reaction could also run in reverse. Water combined with salt and calx would produce an acid. Oxygen was the driving force behind the reaction. So already he's talking about oxygen a lot, which makes me think that the assumption is going to be that all acids contain oxygen, without looking at the answer choices. Lavoisier further believed that other portions of the acidic compound were responsible for the acid's specific individual properties, and this other portion was the acidifiable base. So let's go here. Which of the following assumptions was made by Lavoisier? All acids combine with oxygen as they react. Acids cannot be broken down into other compounds. All acids contain oxygen, and any compound that contains oxygen is an acid. So the answer here is C, because he only knew of the strong acids, nitric and sulfuric acid, and both of those do contain oxygen, so that's where he based his theory. 10. Suppose an acid is allowed to react completely with a metal. Which of the following statements about acids is most consistent with the information presented in the passage? So, the acid can completely react with a metal. If the Lavoisier definition is correct, the oxygen will have donated a proton. If it's correct, the hydrogen will have accepted the proton. And then let's go back for the other two definitions. Liebig primarily studied organic acids. According to his definition, it was hydrogen that was responsible for the common properties. However, not all compounds containing hydrogen would be considered acidic. So, acid is a hydrogen-containing compound in which the hydrogen could be replaced by a metal. And then he recognized a base as being able to neutralize the acid. So, we want to know, first off, which one would be correct. So number 10, we have to combine this and the question in this question stem. So what does it say about protons? And the first sentence in the opening paragraph said that acids are capable of donating a proton. So we need to use donating and donated. So that means we're between F and H. So H says, if the Liebig definition is correct, the oxygen in the acid will have donated a proton in the reaction. They never ever talk, his definition does not talk about oxygen at all, which means it's out of scope. So the answer here is F. The Liebig definition states that the hydrogen in acid is capable of being replaced by a metal. Which of the following findings, if true, could be used to counter this definition? So you'll also see this on the ACT as contradict. Acids, when reacted, release pure hydrogen gas. He says that happens, so it's not going to be A. Acids, when neutralized, form solutions with a pH equal to that of pure water. That one, again, is out of scope. C. In the reaction of sulfuric acid with sodium hydroxide, sodium sulfate are formed. So that does support his definition because the hydrogen here is replaced with the metal, but it doesn't talk about it entirely because it doesn't really, it's not super intense. It shows an example of that, but that doesn't extract it. So that doesn't make Liebig wrong. So some acids, when completely reacted, form pure minerals in water. That leaves us with choice D as the answer, because a hydrogen cannot be replaced by a metal if pure metals in water are formed. So if it just makes a pure metal, so this mineral here is a metal, then the hydrogen's not getting replaced by anything. You have to have a compound here, so that makes Liebig wrong. And our last one, number 12. Adherents of which definition, if either, would predict that hydrochloric acid has a pH of less than 7? He thinks that to be an acid. So acids have a pH of less than 7. pH scale is the only thing that you need to know on the ACT that's actually scientific content. But the Lavoisier definition, that believes that oxygen has to be there. HCl does not have an oxygen, so the answer here is not F. So that means that it is the Liebig definition only, because he's the only one that talks about hydrogens, and he does certainly talk about hydrogens. And we know that if we put HCl and then NaOH together, this base, then you could get NaCl, which is salt, and then HOH, which is water. And you will actually do a lab for this in quarter 4, so you'll get to see that in real time.